November 8, 1942. 0530 hours. Oran Harbor, Algeria. A young American private named Edward Middleton crouched behind a stone wall, gripping what looked like a metal drainpipe with a crude sight welded to its side. German soldiers manning a Panzer III tank 150 yards away had spotted the strange tube and were literally laughing, their voices carried across the dawn stillness in mocking German phrases that needed no translation. 30 seconds later, that laughter turned to screams as a 3.5-pound rocket punched through 3 inches of armor plate and detonated inside their tank. The weapon that would revolutionize infantry warfare had just announced itself to the world. The Germans had a word for it by nightfall: Panzerschreck, tank terror. But the Americans called it something simpler, named after. The weapon that changed armored warfare forever was born from a simple, terrifying mathematical problem that haunted American military planners throughout 1941. German panzer divisions were cutting through European defenses like a blowtorch through paper, and the United States Army had no answer. The equation was brutally straightforward. A German Panzer IV tank carried 80 mm of frontal armor and a 75 mm main gun. An American infantryman carried a Springfield rifle that could penetrate approximately 0 mm of tank armor. The standard anti-tank rifle, the Boys .55 caliber, could penetrate 21 mm of armor at 100 yards, utterly useless against modern German tanks. The 37 mm anti-tank gun, the Army's primary anti-armor weapon, could barely scratch a Panzer's paint at combat ranges. American infantry facing German armor had exactly 3 options, according to the 1941 Infantry Field Manual: run, hide, or die. None of these options won battles. The problem consumed the Office of Scientific Research and Development throughout the fall of 1941. Lieutenant Colonel Leslie Skinner, working at the Aberdeen Proving Ground in Maryland, had been studying the issue since his assignment in March of that year. His preliminary reports made for grim reading. Every existing American anti-tank weapon required either a vehicle to move it or a crew of 4 to 6 men to operate it. Tanks didn't wait for crews to set up heavy guns. Skinner had become obsessed with a seemingly impossible specification: create a weapon that one man could carry, that could penetrate 3 inches of armor, that could be fired from the shoulder, and that wouldn't kill the operator from backblast. Every conventional weapons engineer told him it couldn't be done. The recoil from a projectile powerful enough to destroy a tank would shatter a man's shoulder. The backblast from a rocket powerful enough to penetrate armor would incinerate anyone standing behind it. But Skinner had seen something in 1940 that haunted his calculations: a demonstration by Dr. Robert Goddard, the rocket pioneer. Goddard had shown a small rocket motor that used a shaped charge warhead. The demonstration had been academic, theoretical. Goddard was thinking about altitude records, not armor penetration. But Skinner saw something else: a way to cheat physics. The shaped charge principle, developed by American engineer Charles Monroe in 1888, created a focused jet of superheated gas and molten metal that could cut through armor like a cutting torch. The jet didn't rely on kinetic energy, it didn't have to be heavy or fast. It just had to get close enough to the target to form properly. This meant the rocket didn't need to be massive. It could be relatively light, relatively slow, and still destroy a tank. By December 1941, when Pearl Harbor forced America into the war, Skinner had assembled a small team at Aberdeen. Captain Edward Ewell, a young ordnance officer, joined him with a background in electrical engineering. Major Ronaldo Fiore brought expertise in explosives. Together, they had 4 months to create a miracle: a weapon that could stop Hitler's tanks and be simple enough for a frightened 18-year-old to operate under fire. The clock was ticking. American troops would face German armor in less than a year. The first prototype that actually worked was assembled in a garage workshop at Aberdeen Proving Ground on May 14, 1942, at approximately 2 a.m. Captain Edward Ewell had been awake for 31 hours straight, running calculations on rocket propellant mixtures. The breakthrough came from an unlikely source: a visit to a local plumbing supply store. Ewell had been struggling with the launcher design for weeks. Every iteration was too heavy, too complex, or too dangerous to the operator. The shaped charge warhead was working beautifully in tests. The Monroe effect was focusing explosive energy into a jet that could penetrate 4 inches of armor in laboratory conditions. But delivering that warhead to a tank was proving impossible. Conventional wisdom said you needed a rifled barrel to stabilize a projectile. But rifling a tube strong enough to handle rocket backblast made it too heavy. No soldier could carry it into combat. Smooth-bore tubes were lighter, but everyone knew unrifled projectiles tumbled in flight and missed their targets. Ewell was walking past a construction site near the Aberdeen facility when he saw a plumber carrying a section of standard iron pipe. The pipes were stacked in bundles, 60 mm diameter, lightweight, dirt cheap. Something clicked in his engineer's mind. What if the rocket itself provided stabilization? What if you didn't need the launcher to be precise, just a tube to point the rocket in roughly the right direction? Back at the workshop, Ewell grabbed a 54-inch section of 60 mm iron pipe. Total cost, $1.73. He welded a simple pistol grip from a Thompson submachine gun to the tube, added a basic trigger mechanism connected to an electrical firing circuit, and mounted the crudest possible sight, a wire ring at the front, a notch at the rear. The entire launcher weighed 13 pounds. A child could carry it. The rocket itself was equally simple, almost insultingly so. A 3.5-pound M601 shaped charge warhead attached to a rocket motor that burned for 0.3 seconds. The motor had 4 spring-loaded fins that popped out after launch, stabilizing the rocket in flight through aerodynamic forces rather than spin. Maximum effective range, 300 yards. Muzzle velocity, only 265 feet per second, slower than many pistol bullets. The first test firing occurred at 6 a.m. on May 14. Ewell, Skinner, and Major Fiore set up a captured German armor plate 100 yards downrange, 50 mm thick, the equivalent of a Panzer III's frontal armor. Ewell shouldered the pipe, aligned the crude sights, and squeezed the electrical trigger. The rocket motor ignited with a distinctive whoosh, not a bang, but a rushing sound like a giant blowtorch. The backblast vented harmlessly behind Ewell through the open rear of the tube. The rocket, trailing smoke, flew downrange and struck the armor plate dead center. The shaped charge detonated with a sharp crack. When the smoke cleared, there was a hole in the armor plate the size of a man's fist, with the edges glowing red hot. The jet had punched completely through 50 mm of hardened steel. Major Fiore looked at the smoking pipe in Ewell's hands and said what they were all thinking: "It looks like Bob Burns' bazooka." Burns was a popular comedian who played a makeshift musical instrument made from pipes. The name stuck immediately. By June 1942, the U.S. Army had ordered 5,000 units for immediate production. By August, that number had jumped to 25,000. The weapon that would terrify German tank crews was heading to war. German military intelligence first learned about the American rocket tube weapon in August 1942 through reports from operatives in neutral Portugal. The initial assessment, filed by Oberst, Colonel Wilhelm Ritter von Thoma, head of German anti-tank warfare development, was devastatingly dismissive. Von Thoma's report, dated August 23, 1942, and later captured by Allied forces, laid out the German position with technical precision. The Americans have developed a shoulder-fired rocket launcher that allegedly can penetrate 80 mm of armor. This weapon represents no threat to German armored forces for the following reasons. The report listed 5 critical flaws that German engineers were certain would render the bazooka tactically useless. First, the rocket's slow velocity, 265 feet per second, meant any competent tank driver could simply move. German doctrine trained drivers to continuously shift position when under fire. A slow-moving rocket would hit empty air. Second, the maximum effective range of 300 yards was laughable. German tanks engaged targets at 1,000 to 2,000 yards with their main guns. Any infantryman foolish enough to get within 300 yards of a Panzer would be cut down by machine gun fire long before he could aim his rocket tube. Third, the weapon required the operator to be standing or kneeling, completely exposed, to fire it. German infantry doctrine emphasized that anti-tank weapons needed to be fired from concealment, from prone positions behind cover. An American soldier standing in the open to shoot his tube would be dead before the rocket left the launcher. Fourth, intelligence reports indicated the rocket had no armor-piercing cap, no hardened penetrator, just an explosive charge. Every German tank officer knew that explosive charges detonated on the surface of armor, creating flash and noise but rarely achieving penetration. The idea that a simple explosive could defeat hardened Krupp steel was considered American propaganda. Fifth and most damning, the rocket was unguided. German calculations showed that an unguided, slow-moving projectile fired from a smoothbore tube would have a circular error probability of at least 15 meters at 200 yards. The Americans would need to fire dozens of rockets to hit a tank-sized target. And tanks didn't sit still while being shot at. Von Thomann's conclusion was definitive: this weapon may prove useful against fortifications or soft-skinned vehicles, but poses no credible threat to armored warfare. Recommend no changes to existing tank design or tactical doctrine. German tank crews heading to North Africa in October 1942 were briefed about the American rocket tube, but only in passing, the same way they were briefed about American hand grenades or rifle grenades. It was listed as a minor infantry weapon, not worthy of serious tactical consideration. Hauptmann, Captain, Friedrich Vollmer, commanding a company of Panzer IIIs in the 10th Panzer Division, wrote in his personal diary on October 28, 1942, "Intelligence briefing today mentioned American bazooka rocket. Imagine being afraid of a drain pipe. The Americans are welcome to shoot fireworks at Krupp steel. We'll respond with 75mm shells." By November 7, Vollmer's company was loading onto transport ships in Marseille, France, heading for Algeria. They expected to face inferior American tanks and poorly trained infantry. They were not worried about pipes. Within 72 hours, that confidence would be shattered, literally. Before we jump back in, tell us where you're tuning in from, and if this story touches you, make sure you're subscribed, because tomorrow, I've saved something extra special for you. Major Fiore looked at the smoking pipe in Yule's hands and said what they were all thinking: it looks like Bob Burns' bazooka. Burns was a popular comedian who played a makeshift musical instrument made from pipes. The name stuck immediately. By June 1942, the U.S. Army had ordered 5,000 units for immediate production. By August, that number had jumped to 25,000. The weapon that would terrify German tank crews was heading to war. German military intelligence first learned about the American rocket tube weapon in August 1942 through reports from operatives in neutral Portugal. The initial assessment, filed by Oberst Colonel Wilhelm Ritter von Thoma, head of German anti-tank warfare development, was devastatingly dismissive. Von Thoma's report, dated August 23, 1942, and later captured by Allied forces, laid out the German position with technical precision. The Americans have developed a shoulder-fired rocket launcher that allegedly can penetrate 80 millimeters of armor. This weapon represents no threat to German armored forces for the following reasons. The report listed 5 critical flaws that German engineers were certain would render the bazooka tactically useless. First, the rocket's slow velocity, 265 feet per second, meant any competent tank driver could simply move. German doctrine trained drivers to continuously shift position when under fire. A slow-moving rocket would hit empty air. Second, the maximum effective range of 300 yards was laughable. German tanks engaged targets at 1,000 to 2,000 yards with their main guns. Any infantryman foolish enough to get within 300 yards of a panzer would be cut down by machine gun fire long before he could aim his rocket tube. Third, the weapon required the operator to be standing or kneeling, completely exposed, to fire it. German infantry doctrine emphasized that anti-tank weapons needed to be fired from concealment, from prone positions behind cover. An American soldier standing in the open to shoot his tube would be dead before the rocket left the launcher. Fourth, intelligence reports indicated the rocket had no armor-piercing cap, no hardened penetrator, just an explosive charge. Every German tank officer knew that explosive charges detonated on the surface of armor, creating flash and noise but rarely achieving penetration. The idea that a simple explosive could defeat hardened Krupp steel was considered American propaganda. Fifth and most damning, the rocket was unguided. German calculations showed that an unguided, slow-moving projectile fired from a smoothbore tube would have a circular error probability of at least 15 meters at 200 yards. The Americans would need to fire dozens of rockets to hit a tank-sized target. And tanks didn't sit still while being shot at. Von Thomann's conclusion was definitive: this weapon may prove useful against fortifications or soft-skinned vehicles, but poses no credible threat to armored warfare. Recommend no changes to existing tank design or tactical doctrine. German tank crews heading to North Africa in October 1942 were briefed about the American rocket tube, but only in passing, the same way they were briefed about American hand grenades or rifle grenades. It was listed as a minor infantry weapon, not worthy of serious tactical consideration. Hauptmann, Captain, Friedrich Vollmer, commanding a company of Panzer IIIs in the 10th Panzer Division, wrote in his personal diary on October 28, 1942, "Intelligence briefing today mentioned American bazooka rocket. Imagine being afraid of a drain pipe. The Americans are welcome to shoot fireworks at Krupp steel. We'll respond with 75mm shells." By November 7, Vollmer's company was loading onto transport ships in Marseille, France, heading for Algeria. They expected to face inferior American tanks and poorly trained infantry. They were not worried about pipes. Within 72 hours, that confidence would be shattered, literally. Before we jump back in, tell us where you're tuning in from, and if this story touches you, make sure you're subscribed, because tomorrow, I've saved something extra special for you. November 8, 1942. 0520 hours. The beaches of Oran, Algeria, were still dark when the first American landing craft ground onto the sand. Operation Torch, the Allied invasion of North Africa, had begun. Among the equipment being unloaded in the pre-dawn darkness were 350 bazooka launchers, still so new that many soldiers had never fired one. Private Edward Middleton, 1st Infantry Division, had received exactly 40 minutes of training on the bazooka 3 days earlier aboard the transport ship USS Thomas Jefferson. The instruction had been rushed, almost comical in its brevity. Point the tube at the tank. Press the trigger. Don't stand behind it when it fires. That was essentially the entire training program. Middleton's squad had drawn lots to determine who would carry the bazooka. He'd lost. Now he was crouched behind a stone wall at the harbor's edge, watching a Panzer III tank from the 10th Panzer Division rumble into position 150 yards away. The tank's commander had spotted Middleton and his peculiar tube weapon. Through the dawn stillness, Middleton could hear German voices, laughter, definitely laughter. The German crew had every reason to be confident. Their Panzer III mounted a 50mm main gun and carried 50mm of frontal armor. They had trained for years. The Americans facing them were green troops who had never seen combat. And this particular American was holding what appeared to be a piece of plumbing pipe with delusions of grandeur. Middleton's hands were shaking as he loaded the rocket, a clumsy process involving sliding the electrical contact pins into the launcher's firing mechanism. His training officer's words echoed in his head: steady the tube. Lead the target if it's moving. Aim for the center mass. Squeeze, don't jerk. The Panzer's turret was traversing toward Middleton's position. He could see the main gun elevating. In approximately 10 seconds, a 50mm armor-piercing shell would reduce his stone wall to gravel and him to a memory. There was no time for fear, no time for doubt. Middleton shouldered the tube, aligned the crude wire sights on the tank's hull, and squeezed the electrical trigger. The bazooka fired with its distinctive whoosh, a sound the Germans had never heard before. The 3.5-pound rocket streaked across the 150 yards in less than 2 seconds, leaving a smoke trail like a pencil line across the dawn sky. The shaped charge warhead struck the Panzer III's frontal armor at a slight angle, just below the gun mantlet. The Monroe effect worked exactly as designed. The shaped charge's detonation focused explosive energy into a superheated jet of gas and molten copper, traveling at 25,000 feet per second. The jet punched through 50mm of Krupp steel armor plate as if it were cardboard, entered the tank's fighting compartment, and detonated the stored ammunition. The Panzer III's turret lifted 6 feet into the air on a column of flame and smoke. Secondary explosions followed as fuel tanks ruptured. The laughter had stopped. In its place were screams, brief, horrible, and then silent. Middleton stared at the burning wreck, his ears ringing from the rocket's backblast, his hands still trembling. He had just proven that a $1.73 pipe and a $15 rocket could destroy a $100,000 tank. The mathematics of armored warfare had fundamentally changed. Within an hour, 7 more German tanks had been destroyed by bazookas at Oran. By nightfall, American forces had knocked out 19 Panzers, more than half the German armor in the immediate sector. The German 10th Panzer Division's war diary, captured after the battle, recorded the assessment: enemy possesses new rocket weapon of unexpected effectiveness. Previous intelligence assessments catastrophically wrong. Urgent tactical revision required. The German High Command's first response to reports from North Africa was disbelief. General Oberst Franz Halder, chief of the German General Staff, received the initial combat reports on November 9 and immediately suspected American propaganda or, worse, incompetent tank crews making excuses for poor performance. But the reports kept coming. November 10, 4 Panzer IVs destroyed by rocket weapons near Algiers. November 12, 6 tanks lost to tube weapons at Casablanca. November 15, an entire platoon of Panzer III's, 5 tanks, eliminated in minutes by American infantry near Mejaz el Bab. The crews that survived, those few who managed to bail out before ammunition detonated, told identical stories. Americans with tubes. Rockets that punched through armor. No warning. No defense. Hauptmann Friedrich Vollmer, whose diary had dismissed the bazooka as fireworks just 2 weeks earlier, filed a frantic after-action report on November 14. His company had lost 3 tanks in a single engagement. His report, preserved in captured German documents, marked a complete reversal in attitude. The American rocket weapon is devastatingly effective. Range exceeds our previous intelligence estimates. We observed hits at 250 meters. Penetration capability destroys any German tank currently in theater. Most critically, the weapon requires only 1 man to operate and can be fired from concealed positions. Our tanks cannot identify the threat before being hit. Previous doctrine of closing with enemy anti-tank weapons is now suicidal. The Americans can engage us before our machine guns achieve effective range. Vollmer's report included a tactical assessment that sent shockwaves through German Armored Command: recommend immediate withdrawal of armor from infantry engagement range. Tank infantry cooperation as currently practiced is no longer viable. American infantry now possesses firepower equivalent to anti-tank gun batteries, but with complete mobility and concealment capability. The psychological impact was spreading faster than the tactical one. German tank crews, previously confident in their armor's protection, were now terrified of American infantry. Radio intercepts by Allied signals intelligence units documented the panic in German communications. November 16, 07:30 hours, multiple rocket launches observed. Request permission to withdraw. November 16, 11:45 hours, infantry reported in Trilene. Cannot advance, may possess tube weapons. November 17, 14:20 hours, require air reconnaissance to confirm absence of rocket infantry before proceeding. German tankers were now refusing to advance without extensive reconnaissance, a complete reversal of blitzkrieg doctrine that emphasized speed and aggressive movement. Entire operations were being delayed or cancelled because of fear of bazooka teams that might not even be present. The German response was hasty and desperate. By November 20, new tactical orders had been distributed to all armor units in North Africa. Tanks were to maintain minimum 400-meter standoff from suspected infantry positions. All infantry engagements required artillery preparation. Tank infantry cooperation was suspended pending tactical review. But these measures came with a devastating cost. Maintaining 400 meters from infantry meant tanks couldn't provide close support. Artillery preparation warned defenders and took time German forces didn't have. The fluid, aggressive armor tactics that had conquered Europe were being abandoned because of a weapon that cost less than a tank's radio set. General Feldmarschall Erwin Rommel, commanding Axis forces in North Africa, sent a personal message to Hitler on November 25, "The American rocket weapon has neutralized our armor advantage. We cannot advance. We cannot hold. We cannot win." The weapon the Germans had laughed at was now the weapon they feared most. The bazooka's success in North Africa created immediate demand that stressed American industrial capacity to its limits. By December 1942, the Army had revised its production orders from 25,000 units to 150,000 units, a six-fold increase that sent factories scrambling. But battlefield experience was revealing critical flaws that required urgent modification. The first major issue appeared during operations in the Tunisian mountains in January 1943. Lieutenant James Bradford, 34th Infantry Division, filed a report that would trigger a complete redesign of the weapon. Bradford's bazooka team had engaged a Panzer IV at 200 yards in freezing mountain conditions. The rocket fired normally, but the shaped charge failed to detonate on impact. The rocket simply bounced off the tank's armor and tumbled away. The German tank crew, surprised but unharmed, returned fire and killed Bradford's loader. Investigation revealed a critical design flaw. The electrical firing mechanism for the shaped charge warhead relied on a contact switch that could freeze in cold conditions or fail if the rocket struck armor at an oblique angle. The failure rate in European winter conditions was estimated at 15–20%, completely unacceptable for a weapon that often gave soldiers only one shot before tank return fire killed them. Captain Edward Ewell, the bazooka's co-inventor, was rushed to North Africa in February 1943 to solve the problem. Working in a makeshift workshop in Algiers, Ewell developed an improved M6A3 rocket with a piezoelectric fuse, a crystal that generated electrical current under impact pressure. The new fuse was virtually immune to cold and would function at any impact angle. By March 1943, modified rockets were reaching frontline units. The second critical improvement came from battlefield innovation by the soldiers themselves. Sergeant Robert Hastings, 1st Armored Division, discovered that German tanks were beginning to use spaced armor, thin plates mounted several inches in front of main armor. The spaced armor detonated shaped charges prematurely, before the Monroe jet could form properly, reducing penetration by 60% or more. Hastings' solution was brilliantly simple. He attached a wooden stick to the rocket's nose, extending 8 inches forward. The stick held the warhead away from spaced armor, allowing the shaped charge to detonate at optimal standoff distance. The modification, dubbed the Hastings extension, was officially adopted in April 1943 and increased effectiveness against spaced armor by 300%. Range limitations remained the bazooka's primary tactical constraint. The original 300-yard maximum range meant bazooka teams had to get dangerously close to their targets. Combat experience showed that 40% of bazooka operators became casualties, killed or wounded during or immediately after firing. In response, soldiers developed new tactics documented in revised field manuals. Bazooka teams began operating in pairs, one team firing while another repositioned. They used terrain ruthlessly, firing from gullies, building corners, and tree lanes that allowed rapid withdrawal. They learned to aim for track assemblies and engine compartments rather than frontal armor, mobility kills being safer than attempting penetration shots. By mid-1943, the bazooka had evolved from a crude rocket tube into a sophisticated weapon system with specialized ammunition, proven tactics, and trained operators. But its most important impact wasn't tactical, it was psychological. German armor was no longer invincible, and every German tank crew knew it. Preparing and narrating this story took us a lot of time, so if you are enjoying it, subscribe to our channel, it means a lot to us. Now back to the story. The German response to the bazooka threat was comprehensive, desperate, and innovative. By spring 1943, every aspect of German armor doctrine was being rewritten to account for the weapon that had shattered their tactical superiority. The first countermeasure appeared on Panzer IVs arriving in Tunisia in March 1943. Oberst Heinrich Eberbach, commanding the German Armored Training Center at Grafenwehr, had ordered the installation of Scherzen, side skirts made of 5 mm steel plates mounted 150 mm away from the hull. The spaced armor concept was simple: detonate shaped charges before they could touch main armor, dispersing the Monroe jet harmlessly. Initial results were promising. Lieutenant Thomas Garrett, 9th Infantry Division, filed a report on March 18 describing a bazooka engagement where his rocket struck a Panzer IV's side skirt and failed to penetrate. The rocket hit the hanging plates and exploded, but the tank kept coming. We had to fire 3 more rockets before we achieved a mobility kill by hitting the tracks. German tankers began operating with renewed confidence. Oberstfreiter, Corporal Hans Weber, a Panzer IV driver, wrote in a letter home on March 25, "The skirts work magnificently. American rockets explode against them like firecrackers. We are no longer afraid of their tube weapons." The letter was intercepted by Allied intelligence and caused serious concern among American commanders. But the Scherzen had critical weaknesses that became apparent during intensive combat operations. The thin plates were vulnerable to artillery shrapnel and machine gun fire. Once damaged, they provided no protection. More critically, they only protected the hull sides; the front, rear, and turret remained vulnerable. American bazooka teams quickly adapted, targeting unprotected areas or simply aiming for spots where skirts had been damaged or torn away. The Germans also attempted tactical solutions. New doctrine, distributed in April 1943, required tanks to operate with increased infantry support specifically tasked with hunting bazooka teams. German infantry would advance ahead of armor, clearing suspected positions before tanks moved forward. The tactic was sound in theory but catastrophic in practice. It slowed German advances to a crawl and exposed infantry to devastating American artillery and small arms fire. General Major Wilhelm Ritter von Thoma, the same officer who had dismissed the bazooka as harmless in August 1942, was captured by British forces at El Alamein in November 1942. During interrogation in March 1943, he provided a devastating assessment that was immediately classified by Allied intelligence. "The bazooka has fundamentally altered the tactical relationship between armor and infantry," von Thoma stated. Previously, infantry feared tanks and required dedicated anti-tank guns for protection. Now, every American infantry squad possesses tank-killing capability. German armor can no longer exploit breakthroughs or pursue defeated enemies. The risk of ambush by bazooka teams is too high. The weapon has returned warfare to 1918, where armor cannot operate without overwhelming infantry support. Von Thoma's assessment was prophetic. Statistical analysis by German Army headquarters showed that tank losses from bazookas had increased from 8% of total armor casualties in November 1942 to 31% by April 1943. More concerning was the effect on operational tempo. German armored advances that previously covered 30 to 40 kilometers per day were now achieving only 8 to 12 kilometers due to constant caution about bazooka ambushes. The most telling indicator was casualty ratios. In 1940 to 1941, German tanks typically destroyed enemy anti-tank guns at a ratio of 5 to 1, 5 guns destroyed for every tank lost. Against bazooka teams in 1943, that ratio had inverted to 1 to 3, 3 tanks lost for every bazooka team confirmed killed. The mathematics of armored warfare had been completely reversed. By May 1943, German tank production was being redesigned with bazooka defense as a primary consideration. Thicker armor, better spacing, protective skirts, all added weight and complexity. The Panther tank, rushed into production in 1943, carried 80 mm of frontal armor specifically to defeat bazookas. But the added protection came at a cost: reduced speed, increased fuel consumption, and mechanical unreliability that would plague German armor for the rest of the war. The bazooka's impact expanded far beyond the deserts of North Africa. By summer 1943, the weapon had become standard issue throughout American forces, and its influence was reshaping every theater of war. Sicily, July 1943. The Allied invasion of Sicily marked the bazooka's debut in European terrain: narrow streets, stone buildings, terraced hillsides that offered perfect ambush positions. German defenders quickly discovered that urban warfare against bazooka-equipped infantry was a nightmare. Sergeant Vincent D'Angelo, 45th Infantry Division, described an engagement in the town of Gela on July 11 that became a template for urban anti-tank tactics. We positioned 3 bazooka teams in buildings overlooking the main street. When the Panzers came through, we hit them from second-story windows at 75 yards. The Germans never saw us until the first tank exploded. We destroyed 4 tanks in 90 seconds, then withdrew through pre-planned escape routes before their infantry could respond. The tactic, which became known as vertical ambush, was devastatingly effective. German tanks operating in towns faced threats from above, below, and every direction simultaneously. Tank commanders who previously fought with hatches open for visibility now buttoned up completely, reducing their situational awareness to almost zero. Italy, September 1943. The Italian campaign introduced new challenges and innovations. German forces began deploying Panther and Tiger tanks with armor too thick for standard bazookas to penetrate frontally. American forces responded with new tactics and ammunition. The M6A3 rocket was supplemented by the experimental M10 rocket, carrying a larger 6-pound warhead that could penetrate 120 millimeters of armor, enough to threaten even Tigers from the side or rear. Technical Sergeant Arthur Jennings, 36th Infantry Division, became legendary for a technique he developed during the Rapido River crossing in January 1944. Jennings discovered that by aiming at the junction between turret and hull, the turret ring, even standard bazooka rockets could achieve catastrophic kills by jamming the turret or igniting ammunition stored in the turret basket. His after-action report documenting this technique was distributed army-wide and saved countless American lives. Pacific Theater, 1943 to 1944. While less celebrated than its anti-tank role, the bazooka proved equally revolutionary against Japanese fortifications. Marine Corps units discovered that bazooka rockets could destroy pillboxes, bunkers, and caves that resisted conventional weapons. At Tarawa in November 1943, bazooka teams neutralized fortified positions that had stopped Marine advances for hours. The psychological impact on Japanese defenders mirrored German experiences. Captured documents from Saipan in June 1944 revealed that Japanese forces had developed specific defensive doctrine against American rocket tubes, including dispersed positions and immediate counterattack protocols. The weapon designed to kill tanks had become a universal assault tool. France, June 1944. The Normandy invasion saw bazookas employed on an unprecedented scale. Over 5,000 launchers participated in D-Day operations. In the Bocage country, dense hedgerows that channeled armor into natural kill zones, bazooka teams achieved their highest effectiveness of the war. Lieutenant Colonel James Earl Rudder, commanding the 2nd Ranger Battalion at Pointe du Hoc, reported that bazookas were more valuable than artillery in close terrain. We used them against everything, tanks, bunkers, buildings, even to blast through hedgerows. The weapon became our universal problem solver. German tank crews, now veterans of 2 years of bazooka warfare, had developed their own countermeasures and psychological coping mechanisms. But the fundamental equation remained unchanged: American infantry could kill German tanks, and German tankers knew it. This knowledge shaped every tactical decision, slowed every advance, and contributed to the Wehrmacht's growing defensive mindset. By late 1944, the bazooka had destroyed an estimated 7,500 German armored vehicles, more than German factories could replace. But perhaps more significantly, the weapon had destroyed German confidence in armored warfare itself. The Blitzkrieg was over, killed not by opposing tanks, but by infantrymen with tubes. The bazooka's final chapter in World War II was written in the frozen forests of Belgium during the Battle of the Bulge, December 1944. When German armor launched Hitler's last desperate offensive, American forces, many of them green replacement troops, stood their ground with one critical advantage: bazookas. Staff Sergeant Francis Curry, 120th Infantry Regiment, earned the Medal of Honor on December 21 near Malmedy, Belgium. Curry's citation describes how he single-handedly engaged 5 German tanks with a bazooka, destroying or disabling all 5 vehicles and saving his surrounded company. His actions represented the weapon's ultimate validation. One determined soldier with a tube could stop an armored assault. Throughout the Ardennes, bazooka teams fought from frozen foxholes and destroyed German tanks attempting to exploit the breakthrough. The 101st Airborne Division, surrounded at Bastogne, used bazookas to defeat repeated panzer attacks. German forces that had shocked the Allies with their offensive power found themselves stymied by infantry weapons that negated their armored advantage. Oberst Otto Riemer, commanding the Führer Escort Brigade, wrote in his after-action report, "American infantry showed no fear of our tanks. Every advance was met by rocket fire from concealed positions. We could not achieve breakthrough velocity because bazooka teams forced constant tactical caution. The weapon has made traditional armored warfare obsolete." By war's end in May 1945, American forces had produced over 476,000 bazooka launchers and 15 million rockets. The weapon had evolved through multiple iterations, improved fuses, better propellants, more powerful warheads. But the fundamental design remained remarkably similar to Captain Ewell's prototype assembled from $1.73 worth of plumbing pipe. The bazooka's influence extended far beyond American forces. By 1944, every major military power was developing similar weapons. The Germans created the Panzerschreck, a direct copy scaled up to 88 mm. The British developed the PIAT. The Soviets fielded the RPG series. All traced their lineage to the American innovation born from desperation in 1942. Post-war analysis revealed staggering statistics. The bazooka had destroyed an estimated 10,500 German armored vehicles during World War II. Cost analysis showed that each tank destroyed cost approximately $47 in ammunition. A $100,000 tank eliminated by less than $50 worth of rockets. The economic equation was as devastating as the tactical one. But the weapon's true legacy wasn't measured in destroyed tanks or cost-benefit ratios. The bazooka had fundamentally altered the relationship between infantry and armor. For centuries, cavalry, and later tanks, had dominated infantry through mobility and protection. The bazooka returned lethal power to the individual soldier. One man, with minimal training, could destroy humanity's most powerful ground weapon. Military historians mark the bazooka as one of World War II's most influential innovations, alongside radar, penicillin, and the proximity fuse. The weapon demonstrated that American industrial ingenuity and pragmatic problem-solving could overcome traditional military excellence. Germany had better tanks, better tactics, and more experienced crews. But America had bazookas, and the industrial capacity to produce them in overwhelming numbers. Lieutenant Colonel Leslie Skinner, the weapon's co-inventor, reflected on the bazooka's legacy in a 1957 interview. "We set out to solve a simple problem, give infantrymen a way to stop tanks. We didn't realize we were changing warfare itself." The bazooka proved that technology could level any battlefield advantage, that industrial capacity could defeat martial tradition, and that American innovation could turn a piece of plumbing pipe into a weapon that terrified the world's best army. The tube the Germans laughed at had delivered the last laugh. In doing so, it had written a new chapter in military history, one where the individual soldier, equipped with American ingenuity, could stand against any threat. The bazooka's legacy endures in every anti-tank weapon that followed, in every doctrine that acknowledges infantry's power against armor, and in the fundamental truth it proved: in modern warfare, victory belongs not to tradition or courage alone, but to those who innovate fastest and produce most effectively. The war ended. The laughter never returned. Up next, you've got 2 more standout stories right on your screen. If this one hit the mark, you won't want to pass these up. Just click and check them out. And don't forget to subscribe and turn on the notification bell so you don't miss any upload from us.